you want to improve EV12EQ600 or 605 ADC RF performance over a wide range of input frequency and at any temperature, to accelerate your development, I will show you all the steps to implement ADX4 IP in a Kintex Ultrascale FPGA. ADX4 IP performs an automatic and real-time calibration of the ADC by real-time post-processing treatment, and it works at any frequency and temperature. For instance, you can get nearly a 10 dB improvement on SFDR. Here, with an input frequency near 1 GHz and an ADC sampling frequency of 6.4 GHz. To evaluate ADX4 IP, you can order now the ADX evaluation boards embedding a KU085 Kintex Ultrascale FPGA. And to start the development, two solutions. You can order either an ADX or FMC development board. Now, let's see how to start with a design example on ADX board. First, we must generate Vivado project and FPGA bitstream. Open Vivado and click on Tools, Run Tickle Script. Then select and launch the script available in the design example to create automatically Vivado project. Click on OK. It takes few minutes to complete. At the end of generation, the project closes. To open it, click on the project in the Recent Projects view. You can now generate the bitstream. It takes approximately 1 hour and a half. Now we have generated the bitstream, we can load it in the FPGA. Click on Hardware Manager and open Target, Auto-Connect. Right-click on the FPGA reference, Program Device and Program. Now the FPGA is programmed, we can open a graphical user interface. Go to Design Example Graphical User Interface directory. Open a command window and type python GUI.py com plus the ID of the compor. You can find the ID of the compor in the device manager. We can now configure the ADC and activate the ADX4 IP license. Select the ADC clock frequency, here 6.4 GHz, then program the PLM, then reset the ADC and click on OTP load and ADC configuration to configure the ADC in one channel mode. Then click on Sync to start the serial link, synchronization, and finally click on ADX4 Reset to activate the ADX4 IP license. For this demo, I'm using ADX development board. The embedded PLL generating ADC clock frequency is synchronized with this signal generator generating ADC input signals. Here, a sine wave at 4.5 GHz. So, in the graphical user interface, I have to select PLL external reference, and no window has ADC clock frequency and input signal are coherent frequencies. Now, let's acquire sample data to analyze SFDR performance with ADX4 IP. In Vivado, click on Play button to launch an acquisition. Vivado Integrated Logic Analyzer is waiting for a trigger. In the graphical user interface, click on Reset Data to generate this trigger. Now we can export sample data in a CSV file in the same directory than the graphical user interface Python script. Click on OK. Now we can display sample data clicking on Plot Data. So, with ADX4 IP, we can get an SFDR of 63 dBc. I changed the signal generator frequency to generate an ADC input signal at 1 GHz, and after a new acquisition, I get an SFDR of 66 dBc. This brings us to the end of this video. You learned how to start with ADC EV12 EQ600 or 605 and ADX4 IP. You can get this IP with the ADC for only 15% more per part. Here is the list of the available parts. As you can just copy and paste this IP in your FPGA design, you can see how it can help you to easily improve RF performance over a wide range of input frequency and of temperature at minimal cost and development time. You can find the IP and design example user guides on the EQ600 product webpage. But, of course, if you have any questions, please contact me using Teledyne hotline email address. Thank you for watching.